Hello everyone, in this video we are going to see how to get the eigenvalues for 3 cross 3 matrix. In our last video we saw how to get the eigenvalues for 2 cross 2 matrix. So our matrix is 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. As you see here, this is 3 cross 3 matrix. So first of all, we are going to use this formula, this second method. So for 3 cross 3 matrix, this is a formula we are using in order to get the 3 eigenvalues. Lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. So as you see here, we have S1. So what is S1? S1 is a trace of A. The trace of A is the sum of 3 plus 5 plus 3. So here we have 3 plus 5 plus 3 is equal to 11. So the trace of this matrix is 11, which is equal to S1. So we are going to look for S2. S2 is the sum of minus of main diagonal. It means we remove the first column and first row. You stay with 5 minus 1 minus 1 3. As you see here, plus you remove the second column and second row. Once you remove them, you stay with 3 1 1 and 3 is here 1 3 1 3, and the last one you remove the third column and third row. You stay with 3 minus 1 5 and minus 1. Then you make the addition. Here you get 14 plus 8 plus 14, which is equal to 36. So what is S3? S3 is a determinant of this matrix. 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. So the determinant of this matrix is equal to 36. I hope guys everyone knows how to get the determinant of this matrix. In case if you don't know how to get the determinant of a matrix, check in our previous videos. You will see how to get the determinant. So guys, how we have S1, S2 and S3, we are just going to replace here in this equation. S1 is equal to 11. S2 is 36 minus S3 is also 36 is equal to 0. So in order to solve this equation, first of all we are going to check. We have to start with 1, replace lambda by 1. You see in this equation we have lambda here, here and here. You replace lambda by 1 and then you make a small calculation to see if it's going to give you 0. If it's not equal to 0, you try by 2. You replace lambda by 2 and then you check if it's going to give you 0. If it doesn't give you 0, you check by 3. You replace lambda by 3, you check if it's going to give you 0. So in this equation if you replace lambda by 3, it will be 0. So lambda is equal to 2. If you replace 2 in this equation, it will give you 0. So here we have our first value for eigenvalues. We are going to look for the remaining two eigenvalues. So in order to solve this equation, there are two methods. I prefer to use the easiest method. As you have lambda is equal to 2, just put here, it becomes lambda minus 2. So as you see here, guys, we are going to look for the value which we can subtract by this one in order to get 0. So here you take lambda square times lambda, you get lambda cube. Lambda square times minus 2 gets minus 2 lambda square. This one give you 0. Minus 11 lambda square minus 2 lambda square is equal to minus 9. Here we have a 36 lambda. So we have to make 0 here. We have to put here minus 9 lambda. Minus 9 lambda times lambda gets minus 9 lambda square. Minus 9 lambda times minus 2 is equal to plus 18 lambda. This one is 0. 36 lambda minus 18 is equal to 18 lambda. Here we have 36. So we have to make 18 lambda 0 here. So you have to put here plus 18. Plus 18 times lambda is equal to 18 lambda. 18 times minus 2 is equal to minus 36. So here you get 0. As you can see here, guys, this is the equation of second degree. By this equation, we are going to get the remaining lambda, the remaining eigenvalues. Sorry. Here we have lambda square minus 9 lambda plus 18 is equal to 0. So here we are looking for two numbers which the sum will give you minus 1 and the product will give you 18. Those two numbers, and they are minus 3 and minus 6. If you take minus 3 times minus 6, it will give you 18. If you take minus 3 plus minus 6, it will give you 9. So as you can see here, guys, this is what we call factorization. Lambda minus 3 lambda minus 6 is equal to 0. Lambda minus 3 is equal to 0, and lambda minus 6 is is equal to 0. Lambda is equal to 3. Lambda is equal to 6. So guys, as you see here, for this matrix 3 cross 3 matrix, we got the eigenvalues, the 3 eigenvalues. We get 2 here, we get 3 and 6. Two, 3 and 6. Those are the eigenvalues for this 3 cross 3 matrix. Thank you guys for watching. In our next video, we are going to solve more questions about how to get the eigenvalues. Thank you.